Welcome to an introduction to the MPAI organization's Human and Machine Communication Project, abbreviated HMC. The organization is developing multiple technical specifications, 11 so far. 5 of these are relevant to the new technical specification that we're introducing here. The first listed here specifies a general framework for combining artificial intelligence modules. The AI modules themselves are called AIMs, and the framework for combining modules is the Artificial Intelligence Framework, or AIF. 4 of the earlier specifications related to our new one, they're listed here. 1 is related to audio enhancement within given environments or contexts. 1 is related to conversations conveyed through several modes, audio, video, and text. 1 module is related to descriptions of objects and scenes, and a 4th module specifies the format for avatars that can be passed among applications. Now about the reason for the new specification. MPAI has recognized the need for a specification supporting advanced forms of communication between humans and machines. The standard ought to cover cases where the machine communicates with a human or machine in the current environment and attempts to understand the conversation as a human would, and tries to generate an appropriate response, again, as a human would, and then act as a speaking and viewable virtual human or avatar. Basically, we're looking at the modules that are necessary to enable communication between machines and humans or other machines. And we also want to enable machines to mediate between 2 humans. That's the idea. So here's a summary of the various scenarios. In the middle, you see, sits the machine represented as an avatar in an environment that might be real or might be virtual. Now that central machine can communicate with the human, who may be seen via video in a real space, or might be shown as an avatar in a virtual environment. Or the machine can communicate with the real or virtual scene populated by several real and or virtual humans. Or the central machine can communicate with another machine shown as an avatar. And finally, the central machine can mediate between humans in different cultural contexts, often speaking different languages. In this case, the central machine takes on the role of interpreter. The participants can be seen as real video elements or avatars, and the scenes can be real or virtual. And now we need to define a couple of terms. Entity is a cover term for either a human or a machine. And as we saw, the human can be shown as real video, or as an avatar, while the machine will always be an avatar. Both can be seen in either real or virtual environments. What's a context? Well, context is a short way of saying cultural context. And again, that often includes the language belonging to that cultural context. And how do entities act in scenes with context? They act very flexibly, using text, speech, faces, and or gestures. Now here's a summary of the structure of the HMC technical specification. Structure means the elements involved. The 7 main elements are listed on the left: introduction, scope, and so on. But you see that the use case for human-machine communication is further broken down into 6 sub-elements. Functions here refers to the non-programming sense. What actions are actually performed within this use case? What about the reference model? Well, that's a flow diagram showing the relations among the modules that compose the use case. And we'll be looking at several of those, and so on. You can obtain this slide set and follow the links on this slide to explore the structure in whatever depth you want. Now, a machine is a computing device that receives communication items, and those items are portable avatars, as specified by an existing specification that I mentioned earlier. The machine may be directed toward another machine or toward a human. If it's directed toward a machine, the current machine produces audiovisual scene descriptors or avatars. And if directed toward a human, the central machine produces an audiovisual scene, scene descriptors of the audiovisual scene. Now we're going to present an overview of MPAI's human-machine communication spec. This is the specification's reference model or flow diagram. And as I mentioned a slide ago, there are two main input paths, toward a machine or toward a human. In the first path, a portable avatar serves as the input, and in the second, the input is instead audio and visual material. But either way, the output is a set of audiovisual scene descriptors, and these go to an entity context understanding module, which produces several results of that understanding. One of them is meaning in a suitable semantic representation. Another is so-called personal status of the first participant. That is his, her, or its emotions, cognitive state, and attitude. A textual record of the input and other technical elements. These are fed to a dialogue processing module, which composes elements of the current machine's response. And those response elements go to that machine's personal status display, which is designed to show the emotional, cognitive, and attitudinal elements of the machine's response to the first participant. As we remember, the first participant can be either a human or a machine. And finally, the resulting display elements are fed to either a portable avatar or to a rendering module that will present that machine response in audio and visual form. The next slide just shows a review of the modules we were looking at a moment ago in the flow diagram, summarizing the input and output of each module. We'll take just one example, that is the personal status display. That's the second from the bottom. It receives the response of the machine participant and produces a portable avatar that will handle the audiovisual elements of that response. We would like you to appreciate the power of MPAI's artificial intelligence framework, which arises from its flexibility and range. The AI modules, artificial intelligence modules, can be basic or can be composite, which means composed of lower level modules. The implementer is free to decide which modules to use as long as they support the defined inputs and outputs. The overall performance of an implementation depends on that of the actual selected technologies, but it's really important that the future remains open and that those technologies can always be replaced by later or better ones. Now here's a closer look at a module we've already seen, the one that handles the integration and description of audiovisual scenes. What comes in is a portable avatar in the standard format specified elsewhere, and what comes out is a set of descriptors of the audiovisual scene, again in the standard format. And likewise, now for a peek inside a composite module that appeared as a black box in the high-level diagram we saw a few slides ago. What about description of the audio scene? How is that handled? Well, each submodule needs to know the geometry of the relevant microphone array. The audio analysis transform module can then receive and handle multi-channel audio. And that audio is further processed in stages: audio analysis, source localization, separation and enhancement, synthesis transform, and finally description multiplexing, in which the geometry and audio objects come together. The output is a set of audio scene descriptors. Now for the composite module called entity and context understanding. AV scene, audiovisual scene descriptors enter on the left, both visual and audio. And at the top right, we need to compose, that is to multiplex, the first participant's personal status. That would be the emotion, cognitive status, and attitude of the first participant, which might be a human or a machine. The other modules work together to deliver that participant's meaning in a standard semantic representation and identifiers. You might notice also that the text that results from speech recognition can be translated into the text of a specified target language. And that job is handled by a module in the upper right, second from the top. There may be visual objects in the current scene. And this module that we're looking at now has the task of identifying them. Identification might be assisted by humans in the scene, for example, by pointing. And for this purpose, the input includes body descriptors, the finger, for instance. Also, in the input are the scene geometry, visual objects not yet identified. The output will then be the identifiers, the IDs of the identified visual objects. Now here's an interesting module for you. It relates to the first participant's personal status. Remember, that's its emotions, cognitive status, and attitudes. The module gathers that information from the participant's face, body, speech, and text. And each such element has a description and interpretation stage. And then all the elements feed into a multiplexer or combiner. And out comes the first participant's personal status, nicely packaged. But then we need to enable the machine to respond. The response will include the machine's text and its own personal status, passed along as text plus a status package. But the next stage takes that information plus information about the machine's identifier and elements, runs this information through modules that produce machine face and machine body descriptors, and composes a portable avatar that it can pass along. That machine avatar, plus information about the user's point of view, enables a module to finally render the audiovisual scene, render its audio and visual elements, plus a text record for good measure. So it turns out that quite a bit goes into managing and rendering interchanges between humans and machines. However, as evidence of the flexibility and the consequent power of the MPAI framework, much of the work that we have just been reviewing in the human and machine communication technical spec is handled by data types previously developed in separate standards. It's been necessary to add only one composite module, entity and context understanding, and one basic module, audiovisual scene integration and description. And so, now what? With the new specification thus defined, the next requirement is to develop reference software with conformance tests and performance assessment for that software. Modules developed in other technical specifications will be reused as much as possible. This is an exciting project with a breadth of application that ought to be obvious. You are cordially invited to take part in it. Thanks for listening.